Hello and welcome to Module 12, Network Security Infrastructure. So in this module, we are going to talk about the network topologies, how networks are connected together, logical and physical. And then we'll talk about the different types of network security devices that you can use to protect your network and the different types of network services that are available for us. All right, so make sure that you have Microsoft Word open so you can take the notes that I asked you to. All right, so when we're talking about network topologies, you need to understand the icons that represent the different devices that connects in the logical and the physical topology. So for example, end devices are like desktop computer will have an icon like that, laptop, iPhone, and so on. The intermediary devices, the interconnection devices, the communication devices that allow these devices to communicate. So you'll have the LAN switch, the router, the fireplace. So you should be familiar with a lot of these symbols that identify these devices. And then you have, of course, the network media. This is wireless. This is when you're directly connected in a devices in a LAN, and this is what connects routers in a WAN, right? Okay, so physical and logical topology, what's the difference between them? This is very important, so please write these two statements down. The physical topology is how do you connect devices together physically? So you should be able on your first day on the job, no matter what job you got, this is something that you could do, by the way, and you should definitely do this. And if you went to your first job, and you should be able to draw a physical topology and the logical topology of the network that you are going to be responsible for. You should be able to trace all the wiring to what switches they connect to, and which router and how you are connected. So you should be able to draw this. You may use the software Visio to do this. You can even use your packet tracer to draw your physical topology. It's very, very important. If you are going to troubleshoot or maintain or upgrade your network or find a way to make it scalable, to have better performance, to secure it, you need to understand how these devices are physically connected. All right, so you write down the location of where they are and which switch they connect to. On top of that, you probably want to all use, do the logical topology. Write down all the addressing of each subnet, and the more details about, so logical topology is more the software configuration of these devices. And if you can write down which, if they are connected to a server, or if they're connected to, if you have a 2019 server, which location, what department are they located in, which email server they connect to, all of that. Web servers, or which file servers they connect to, the IP addresses of each of the devices of the networks, and what type of firewall or security settings do they have? Do they have full access to the internet? Is the router enabled with NAT or not? All of that information should be written down. Not necessarily on top of these devices, but at least you should have the IP addresses of each network, so you'll know exactly who's connected where. So that when you're troubleshooting, you'll know exactly what to do. Is that clear? So the physical and the logical topology, you should be able to do that. If you pass the CCNA courses, or the CCN exam, you should be able to draw the physical topology and write down all the addressing on top of it. That makes it, the logical topology, how data flows and where they connect to. All right, so the network comes in many, many sizes, and I think we discussed this before. You can have a small office, home office. You can have one or two computers connected to a modem, or you can have a small home. You just do it, this is your work at home. You can have a medium to, one building to a large company, or you can have, or maybe on campus. That's the enterprise network. Or you can have, you know, a company that is really huge and they have branch offices all over the world. So, you know, networks can come in many, many sizes. So what is the difference between a LAN and a MAN? And I think we've discussed this earlier. A local area network is where everything is owned by the company. Everything that is connected to the devices, the wiring, everything. You control everything. It becomes a WAN is when you need to go outside to reach another office or another LAN or another device. So if you have to to pay for a service provider to connect you to a remote user, then you are connecting to a WAN. So this is a WAN and these are a LAN. So a WAN is the interconnection. So write this down. A WAN is the interconnection of LANs that are in different geographic area. Local area network is something like in a building or an enterprise network where you own all the devices, okay? And also note that a WAN, it has to be in different geographic area and you'll have to use a service provider to connect you. And that service provider may set you up with a VPN or may set you up with different types of connection, PLS or frame relay or whatever. All right, so please take these two. You can take a picture of this is will juxtapose both the LANs and the WANs to show the difference between them. Okay, so write this down also. A LAN is a network infrastructure that spans in a small geographic area. And remember, it's like in a building and they interconnect to each other. A WAN is when you're connecting LANs together. So the interconnection of two LANs in different geographic area. All right, so how do you design your network? You should definitely have 3 layers. You can split this in half. This is just for redundancy, so you can have system fault tolerance in case a router or a firewall is down or a layer 3 is down. There's always a backup. Okay, but you should have a core layer where everything goes through. So you go through the firewall, then you go to your layer 3 switch into a distribution layer. So this is, for example, this is the company where you can have the email for all the users connected here. The distribution layer, this is where all the departments branches out from. No users should be connected to the distribution layer or the access layer. So this is where you can connect multiple VLANs maybe, or multiple switches. The switches at the access layer, this is where all the end devices connect to. This is where all the communication happens. This is, you can have multiple VLANs. So if you're in a school environment, you may have students on one end. You can have also maybe faculty, administration. You can have the registrar, you know, so when everything goes in, it distributes depending on who the emails are for or the data goes to. So you can break it up easier. When you have this hierarchical method, so please write this down, the hierarchical design method for a WAN or a LAN. The access layer, the distribution, and the core layer. The core is on the top, then you get the distribution, then the access. This is the best way to design your local area network because it's more scalable, so you can add more LANs much easier, you know, increase without any compromise in performance. It's more secured. It's better for management as well. So the benefits of a 3-layered network design model, the hierarchical method, is better security, scalable, better management, and much better performance. You definitely want to do it this way. But if you go into a network where the design is already a mess, so it's probably, and after you draw up your physical and logical topology and you take a read on it, you can probably have a better understanding how you can increase performance, increase security, and have better management of the networks when you redesign it into a 3-layer design such as this. Now, if you have a smaller network, you can have a collapse where the actual, you don't have to have the core layer. You should have a connection. You can have one distribution layer that goes directly to the access layer. Most networks are designed this way. All right, so another video to watch. Don't forget that. Okay, so common security architecture. So how do we secure our network? So one way to do it is you can have your private network, and this is the public. And you can actually set up firewalls to allow everybody that, if the connection is initiated from inside the LAN, they can go out, in and out. But any connection connected from the public, the untrusted network, you can block them. So that's one easy way of doing it, right? Another way of doing it is to have a demilitarized zone. So please write this down for a demilitarized zone. What is a demilitarized zone? Anything that you want the public to access, such as an HTTP server or a DMS or a DNS server, you put it outside your LAN, your private LAN. Of course, you still want to protect it. People still have to go through it. So in case anything goes wrong, they did not access your network. Right? So you can set up the firewall to say, I can access if you are in a private inside network, you can access the DMZ and you can access the public. But the public cannot access me, and the DMZ cannot access me as well, the private that is. The public can access the DMZ and vice versa. You can set this easy with the DMZ. And you can do that by the zone-based policy firewalls. So this is one easy way to configure firewalls. All you have to do is identify which is your private LAN, which is the DMZ, and which is the internet, and so on. So once you have so you can say if you are from zone 1 or zone 2, then you can go to the public and you can go to the DMZ. If you are from the zone from the DMZ, you can go to the public and vice versa, but you can't go into the LAN. But if you are from zone 1, you can go anywhere you want. So that's what is meant by it. It's much easier than to set up rules and access control lists on in the firewall. By creating zones, it's much easier. It all depends on which zones you're coming from. You'll be allowed to go or not to, permitted or denied. All right. So let's look at some security devices that are available for us. Of course, the firewall. The firewall is, so write the definition of it right here. But technically, the firewall is like, analogous to a firewall is like a security guard in front of the building. He has a list of who's allowed, who's permitted, and who's denied. So if you're on a list to be permitted, a packet will be allowed to go in. If not, you'll be denied. That's all it is. That's what a firewall is. So there's a lot of security issues with a firewall. Somebody can pretend to be a legitimate user. They may spoof his IP address, and the firewall will not know that. Will allow you in. Firewalls cannot read encrypted data. They have to be decrypted. So there's a lot of other things that you can do to bypass the firewall. All right, so take a picture of this. These are the benefits of the firewall. Just remember a security guard when you're talking about a firewall. And he has a list of who's allowed to go in and out. But remember also the direction is that security guard looking for people coming into the building or leaving the building. That's very important. You may set up, configure an access list for a firewall, but tell the firewall, check data leaving the router instead of coming into the router. That could be an issue. All right, so misconfigured could be a real big problem for firewalls. Again, take a picture of this. All right, so please read the benefits and what their limitations are. Oops. Stateless firewall, let's go back to here. This packet filtering, the simple way of doing firewall. So imagine that you are, I'm going to go with the analogous with a security guard. The security guard looks at what you have. If your name is on the list to be permitted, he lets you in the building. And he doesn't keep track, doesn't keep state of where you are, your connection, where you're going. He doesn't care. Right? And that's not good. That's stateless firewall. It's quick and easy though. Stateful firewall, on the other hand, is going to say, oh, you're going into the building? Okay. Where you're going? You're going to room 128, and he's going to keep track and make sure that you went to room 128 and you didn't go anywhere else. So that's stateful. It's going to keep track of the state of the connection. So write this down. That's very important. That's the most widely used types of firewall, these 2 bullet points. So he's going to make, and if you deviate and went somewhere else other than room 128, he's going to cut off the connection. So stateful firewalls will allow you only to what you are authorized to go to. And it keeps track of the state, the connection, the state of the connection. And they do that by looking at all the labels at the session layer, the connections. Because it can release the session if you digressed and went somewhere else. There's application firewall, application gateway firewall. They can actually check the content. So imagine that you are in the building. Here's the best way to have a firewall. Not only are they going to allow you to go to room 128 and keep track of it, but they're going to look at the content of what you are bringing into room 128. So that's up to the application layer to see if there's any malware that you're carrying with you, or you're accessing something that you're not supposed to. So that's what the application gateway firewall is. Okay, so write these 2 bullet points for it. All right, and these are the new generation firewalls that Cisco offers. There is the 500, we have these in the labs. Then you have the integrated intrusion prevention system, the IPSs. They look for denial of service attacks, for example, and things like that. So let's discuss some of these new generation firewalls that are available for us. The host-based firewall are the ones that are installed software on your PC. Microsoft Windows Defender comes that, and you'll notice that, for example, the Windows firewall will deny echo replies. So you will not reply to anybody that's pinging you, right? So you can actually change that rule within that firewall if you want to be able to reply to that. So in the lab, we usually do that because we want to be able to ping each other. We have to disable that rule in the Windows Defender to allow us to ping each other. So there is the transparent firewall and the hybrid firewall. But you should know that the host firewall is the one that is installed on your end devices. There is also devices called IPSs, the intrusion prevention systems, and the IDSs, the intrusion detection systems. And what these guys do is they look for signatures of attacks. So they may be legitimate packets that are going, but they are constantly, for example, they're trying to overwhelm the server by sending it bogus packets. And IPSs will be able to detect the signature of this type of attack and stop it. Firewalls cannot stop that because firewalls is only either let you in or let you out. So you need an IPS system to detect this type of attack. So an intrusion prevention system, you put it in line with the incoming all files. Every single packet has to be evaluated and either let through, and if you notice an attack, according to the signatures that you have, you can drop it. The problem with IPS is because you put it in line with all the data that's coming into the network, it's going to hinder the traffic. So there's going to be a little bit of delay as data going through. All right, so IDSs, on the other hand, are placed inside the network. Please take a picture of this, okay? And IDSs, it will detect the attack. It's not placed inside. I think there's, and also take a picture of this. The different types of IPSs. We'll get to that IDS in a second. So there is the host-based, ones that are placed on your host, called the HIPs, HIP or NIP. So HIPs are the host-based IPSs. This is software that is placed on your end device, your laptop maybe. And the network base is the one that are placed on, he's the vanguard that gets all the data before it enters your network. So write down on the advantages and disadvantages of a HIP. Okay, so here is for example, your network base IPS. It stays in line, so when the data goes in after the firewall, you sense it. And if it's good, you let him through. And you do another sensor maybe inside just to double check. Okay, so these are IPSs. They're in line of the data as it goes through. Okay, it's important to remember that. Most people would want to use, definitely they want to use an IPS. Because if the signature of an attack is captured, it's stopped from going into the network. That's the advantage. But it slows things down a little bit. Here are the different types of devices that Cisco offers. There is the Cisco Advanced Malware Protection. This is for like viruses and things like that. Then you have Web Security, the WSA. So this is for web pages and web servers. And you have the Email Security Appliance. So those three different appliances are what Cisco offers. I think you should take a picture of this because if you ever decide to take the CCNA test or the CyberOps test, they will ask you about these different devices that Cisco offers to protect your network. Okay, so to control, okay, wait, hold on a second. We never talked about the IDSs. The IDSs, let me see, hold on a second. Let me see if okay, no, we didn't go. I have to go back and we have to explain to you what an IDS is because we explained what the IPS is, but we never really discussed in details what the IDS is. So let me just go back one more. Okay. Assuming that a sensor could be inside in here, inside the network, assuming there's no sensors, and this could be attached to the network. So an IDS would be, this is connected to a switch. Imagine this is connected to a switch. So when the data goes in the network, to let it go through and enter, you may detect that there's an attack, and then you can instruct the firewall to stop the packet from going through. The advantages of having an IDS, remember, assuming you don't have these, is you let the traffic flow smoothly. It doesn't affect the traffic at all. It doesn't hinder the traffic at all. But the problem is that if there is an attack, it's too late. It's already inside the network, even though you may be able to stop it. So nobody really try to use IDSs. They go for IPS systems. All right, let's go back to security services. All right, so you can actually have your routers act as a firewall by creating an access control list and placing it on the interfaces of the router, who's permitted and who's allowed to go and who's allowed to come into the network. That's what the ACLs are. So we spent some time doing that in our CCNA class. Okay, so write down the ACLs and there's 5 bullet points for ACLs. Okay, you should be familiar with how to configure ACLs. There's a standard list which allows you to either permit or deny traffic according to the source IP address. And there's an extended list which you can have actually more options. You can deny or permit packets according to which protocol you're trying to reach, where you're coming from, your source IP address, your destination IP address, port numbers, and so on. So extended list gives you more control of what to permit and what to deny. Okay. Then we have in the SNMP, the Simple Network Management Protocol. Write the first bullet point and the second bullet point, including these 3 bullet points. SNMP is designed to gather information from devices, put them in the memory, and evaluate all that data that is given to you. okay, to manage the network. So if this is the SNMP manager, he goes out and gets information, sets out a get signal, and all of these in their memory, they have information that is saved. These are called, all of them are SNMP agents. They send traps information to the manager. The manager may also go and configure by using a set command to the agents. He sends information to change some values in those memory. Okay? NetFlow is a protocol that's a Cisco proprietary protocol that is used to check the traffic. So you can evaluate the traffic. So please write that down, the first 2 bullet points, including these bullet points. So you can monitor the traffic and find out where you can improve the performance. This is really not a security issue. It's more for traffic purposes to increase the performance. So you can find out where the bottlenecking is and see what you can do about it. Port monitoring. So this is where you actually have, for example, so you can have one port. Let's say this is the IDS system that I talked about. So all the data that goes in goes to everybody else, but give me a copy of it. So that's called port mirroring, right? So we will be able to configure that. This is where your IDS system is. So all the packets, or everything that goes in, I get a copy of it and I evaluate it to see if it's an attack or not. But you have to configure this port to the switch to have this port to be mirrored, which means every frame that comes in, I get a copy of it. So write this down, that statement down for port mirroring. That would help you set up an IDS system. A syslog server. A syslog server is a server that keeps track of every event that happens on the network. So if the switches went down, a protocol, whatever you did, you can send that information to the syslog server. An interface went down, the routing protocol learned a new route from somewhere, you changed the DHCPs, whatever. All that information goes in here. So you can actually go in there, look at all the events that happened, and you can evaluate if there's a problem. If you have, for troubleshooting purposes. So you can always access the syslog server and see all the event that happened before and after an attack or a problem that occurred. The same thing is on your regular PC. You have the event viewer, right? The event viewer on your laptop or your computer in Windows keeps track of all the events that happened, right, on your computer, so that you can use that to troubleshoot your PC. All right? Write the first bullet point for syslog service. Okay, the network timing protocol, NTP. This is to make sure that all the servers, all the networks are synchronized with the same time. Okay? Same time and date. Because you don't want, because what happened when you are passing data, updating the routing protocols or files, everybody is stamped with the time. You don't want to update, if you get an update from a router that has an old time and date, you're not going to accept it because you think it's too old. But if everybody's in sync, according to the update, if it's the newest one or not in comparison to the one that you have. Okay, so NTP is very important. Write the first 2 bullet points. We're not going to get into the, how to set them up. We'll do that in a different class. Then you got the AAA servers. The AAA servers is mainly, please take a copy of this, take a screenshot of this. The AAA servers are really designed for authentication, authorization, and accounting. You have 2 types of servers, the Radius, the RADIUS, and then you have the TACX server, TACX Plus, I think. This is the Cisco proprietary. So every time a user comes in and wants to be authenticated, they are going to be authenticated. Just give me 1 second. All right, so the AAA servers, so when you send in your username and password, you'll be sent to a server, either the Radius or the TACX server, where you are authenticated. Authenticated, you're going to validate the username and a password. And once you are authenticated, then you are authorized. Authorized meaning, depending on how you are set up and what you are authorized to access and not access, what resources you are permitted to have access to. And then that's authorization. And then you can keep an account. The AAA server will keep an account, what you have done, when you logged in, when you logged out, what you have accessed, and so on. So the AAA servers, you can configure that easily. We can, even your router can actually do something like that. Okay. So those are, take a picture of this. There's the Radius servers. This is an open. Take a picture of this, okay? Because I know this comes up on the exams a lot. And write down the statement too. So you'll know that what the name of them, what they stand for. The TACX Plus is a Cisco proprietary. It uses TCP. It's more widely, it's for Cisco devices. This is, the Radius is an open source. It's almost for everybody uses this, obviously, if it's non-Cisco, right? Which is better? TACX Plus if you have Cisco devices, because it's more secured and all your data is encrypted, and you have more options when you are doing it. Radius still works beautifully, and everybody else is using it. So if you ever did any dial-up, most likely you use the Radius server to dial up into a server to have connection to. VPN. The least expensive way to connect a LAN to another LAN is to go through the internet. But the internet is an unregulated network. So what you want to do is you want to create a virtual private network, a network that is private, virtual, meaning using software that only the central office and the branch office can be able to decrypt the data. So what you do is you encrypt the data using a key and then re-encapsulating it in another packet, like that's called in a tunnel. So you have an encrypted data encapsulated in a new network. That's the best way to do it. You're still prone for denial of service attack, but if you want to connect securely over the internet, the least expensive way is to set up a VPN. And you can even do it yourself. You don't need a service provider to do that. So write all these bullet points for a VPN. That's very important. And that ends the chapter. All right, beautiful. So please take all the notes that I asked you to and submit them. And I will see you on the next